In this video, I will show you how to graph a piecewise function. So this function has three pieces. You can think of this first piece as y equals 4, and I will graph it in blue. You can think of the next piece as y equals x to the third power. I will graph that in red. You can think of the third piece as y equals the square root of x plus 3, and I will graph that in green. Let's start with the blue piece of the graph. Because this is a piece of a function, it is going to have at least one endpoint. So this domain, the domain of the blue piece, will tell you what the endpoint is going to be. So the endpoint of this piece of the graph is going to be negative 5 comma something. We need to know what the y value is though. So for that we will look at this equation. Y equals 4. Alright, so that was simple. So the y value is 4. So this is going to be the endpoint. This is going to be an open circle because we want the x values to be less than negative 5, not equal to negative 5, so open circle. And we should be traveling to the left. Okay, we want the left part of this line. This is a linear equation. Because of the less than, that tells us that we want the left part. So let's do that. Open circle at negative 5 comma 4. So here's negative 5 comma 4. Here's an open circle. So listen, the function y equals 4 is a horizontal line at 4. We've memorized that. So this is a horizontal line, but we want the left part of the line. So we will draw our horizontal line going to the left, and that is it for the blue piece of the piecewise function. Okay, now let us graph the red piece. The red piece is going to have two endpoints, okay, because of these two x values. Each one will correspond to an endpoint of this piece of the graph. So I'll have an endpoint at negative 2 comma something, and I'll have another endpoint at positive 2 comma something. Now I need to know what the y values are going to be. So y equals x to the third power. So what's negative 2 to the third power? That's negative 8. What is positive 2 to the third power? That is positive 8. So those are the y values. These are going to both be closed circles because or equal to. All right, so both of these points are included. So we are talking about a closed circle and another closed circle. All right, and then we will just connect them. Okay, so let's see, negative 2 comma negative 8. All right, that's a big gap right there. All right, anyway, negative 2 comma negative 8 is going to be right here. And then positive 2, positive 8 will be right here. Now you can't just draw a straight line through these. We need to figure out what's going on the inside. This is not a linear function. So what I'm going to do is make a quick table of values for this. Okay, so here's my table of values. Okay, so I have x and I have x to the third power. You know, maybe I'll put y equals x to the third power. Because I know you're used to having an x and a y, so I'll say x and a y, but I know that y equals x to the third power. So we need x values between negative 2 and positive 2. So we already have negative 2, so what's left? So then I would have negative 1, and then I will have 0, and now I'll have positive 1, And then that brings me back to positive 2, which I already did. So let's find these three values. So negative 1 cubed is negative 1. 0 cubed is 0. Positive 1 cubed is positive 1. So I need to include these three additional points on their graph. So negative 1 comma negative 1, 0 comma 0, and 1 comma 1. So you can see that this is not a straight line, this is a curve. Okay. All right, so this portion of the piecewise function, this piece of the function should look like this. Okay, what's next? It's time for our third and final piece of the function. Y equals the square root of x plus 3. Again, we are going to have an endpoint with an x value of 3. So my endpoint is going to be 3 comma something. So 3 comma what? Well, if I plug in 3, that's going to be 6. So this is going to be the square root of 6. That doesn't help me a ton. It would be helpful to have a decimal approximation. So, grabbing the calculator real quick, I'm doing the square root of 6. That's 2.4. All right, so this should be an open circle. So I'm looking for an open circle at 3 comma 2.4. 2.4 open circle. Okay, so something like that. Now, because we want the values, the x values, to be greater than 3, when we make our chart for this, okay, let's make a little chart. Okay, so we have x values, and then what was this? The square root of x plus 3. So we have the square root of x plus 3. We're going to pick x values that are greater than 3. So I'm going to pick, for example, 4 and maybe 5. All right, let's just see how it goes. I might plot more points. Let's see how it goes. Okay, so if x is 4, then this is going to be 7. So that's going to be the square root of 7. So I'm using my calculator to help me out. So that's 2.6. If x is 5, that's going to be 8. So let's see, the square root of 8. That's 2.8. This is not moving up super fast. Let's do some more. If x is 6, then that's 6 plus 3 is 9. So the square root of 9 is 3. All right, this is probably going to be enough. Okay, so I've got 4 comma 2.6 would be about here. 5 is 2.8. And then 6 is 3. Okay, so I see what's happening. This is a very, very shallow graph. So if I keep going, it's going to look something like this. All right, and that's it. That's what this piecewise function is going to look like. All right, so that's it for number 7. Number 8, let's graph this crazy piecewise function. So the first piece is y equals absolute value of x minus 5. Okay, I'll graph that in blue. The second piece you can think of as y equals 4x minus 3. I'll graph that in red. And the third piece you can think of as y equals the square root of x. And I will graph that in green. Let's start with the blue piece. Because this is a piece of a function, it's going to have at least one endpoint. This number right here in the domain of the piece tells me the x-coordinate of the endpoint. So I will have an endpoint at -3 comma something. What's the y value? Well, to get the y value, I need to take this x value and plug it in. So that would be, so this would become the absolute value of -3 minus 5. Okay, so that's the absolute value of -8, which is +8. So I have an endpoint of -3 comma 8. This is going to be an open circle because the x values have to be less than -3, but not equal to -3. So this point is not to be included, so that'll be an open circle. So here's the endpoint. Open circle at -3 comma 8. Okay. We need the x values to be less than -3. So I'm going to do a chart. But I want the x values to be less than -3. So that means, for example, -4, -5, -6. So my y values are absolute value of x minus 5. Okay, so if x is -4, then I have the absolute value of -4 minus 5. That's the absolute value of -9, so that's going to be +9. Okay, this one is going to be the absolute value of -5 minus 5. So that's -10. Absolute value of -10 is +10. And here I'll have the absolute value of -6 minus 5. That's -11. Absolute value is +11. So these are the points. So -4 comma 9 would be right here. -5 comma 10 is right here. -6 comma 11 is right here. So this is forming a nice straight line. Okay, which makes sense because an absolute value function forms a V shape, so we must be looking at this portion of the V. Anyway, that's it for the red piece. The blue piece. Let's move on to the red piece. Now, looking at the domain of the red piece, I see that there will be two endpoints. These are the x values of the endpoints, -1 comma something to 3 comma something. I need the y values. So I will plug in -1 into this function. So I'll do that off to the side. So y equals 4 times -1 minus 3. That's going to be y equals -4 minus 3, so y is equal to -7. Okay, now let's do the same thing with 3. So y is equal to 4 times 3 minus 3. So y is equal to 12 minus 3, so y is equal to 9. These are the endpoints. Okay. The first endpoint is a closed circle because of the or equal to, and the second endpoint will be an open circle. So it'll be a closed circle and then an open circle. So let's graph that. So -1 comma -7, closed circle, and then we have 3 comma 9. Okay, open circle. So I just need to connect these points up. I can do it more efficiently if I pay attention to the fact that the slope is 4. So that means as I go along, I'm going up 4 over 1, sort of like this. Up 4 over 1, up 4 over 1, and up 4 over 1. So that will just help me draw the line a little bit better. All right, so there you go. That's the middle piece of the piecewise function. Let's do one more. All right, the last piece is the green piece. This piece will have one endpoint. Looking at the domain of the green piece, the endpoint is going to have an x value of 4. But 4 comma what? Well, if I plug 4 in, substitute for x, square root of 4 is 2. So therefore, 4 comma 2 is the endpoint. And this is going to be a closed circle. So this should be a closed circle. So let's do a closed circle at 4 comma 2. All right, this will be the endpoint. Now let's do a table of values. Okay, so here comes my table of values. And remember that y is equal to the square root of x. That's the function for this piece. Also remember that we want the x values to be greater than or equal to 4. We've already done equal to 4. So now greater than 4 would be things like 5 or 6 or 7. Since I know that I'm doing the square root, I would love to get 9 in here. So how about if I do this? I'm just going to skip ahead. Let's do 5, 7, and 9, for example. Okay, now the square root of 5 is 2.2. All right, how about the square root of 7? That's 2.6. And then, of course, the square root of 9 is 3. So these points are all very close together. So I definitely didn't need more points in there to see what's happening. Okay, so at 5, we're at 2.2. At 7, we're at 2.6. And then at 9, we're at 3. Okay, so this is what's happening. All right, I mean, it's going to look pretty linear, but technically, a square root function is like this, but the reason why it looks so linear is because if you do a square root function, then it goes like this, okay? But if you just look at one part of it, that looks like a straight line, but it's not. All right, but anyway, we're done. All right, this is what the green piece of the piecewise function would look like. So you can see overall the look of this piecewise function. Okay, and that'll do it for problem number 8. All right, let's graph one more piecewise function. All right, the first piece you can think of as y equals negative 3x minus 1. I'll graph that in blue. The second piece, y equals 0.5x plus 5, I will graph that in red. The third piece you can think of as y equals negative absolute value of x minus 5 plus 3, I will graph that in green. So first let's talk about the endpoints of each piece. Each piece is going to have at least one endpoint, and these are the x values of those endpoints. So I know I will have an endpoint at -1 comma something. All right, I need to know what the y value is, so I'm going to substitute -1 in right here. So that's going to give me -3 times -1 minus 1. That's +3 minus 1, so that's 2. So there is the endpoint. This will be a closed circle because of the or equal to, showing me that this point is to be included. So closed circle at -1 comma 2. This is the endpoint of the blue piece. Okay, this is linear, and I want to go to the left because I want the x values to be less than or equal to -1. Okay, so when it's not linear, I usually will make a table of values, but I don't need to do a table of values when it's a straight line because I know that this -3 is the slope, like rise over run. So if I were going to the right, I would go down 3 over 1, like this. Okay, -3 over 1. So I would go down 3 over 1. But I don't want the points going to the right. I need the points that are going to the left, less than. So if I follow that same pattern backwards, it would be up 3, left 1. So if I go up 3 and left 1, up 3, left 1, up 3, left 1, I can see that this part of the line goes like this. All right, and I'll just erase that extra mark that I put. So there is the first piece of my piecewise function. Okay, I find that to be easier than making a table of values. The red piece is also linear, so you will see me do the same thing again. But first of all, this red piece has 2 endpoints. Because of the -1, I know that the first endpoint is -1 comma something. Because of the 3, I know that the second endpoint is 3 comma something. Now I need the y values. So 0.5 is 1/2. So I'm just going to start using 1/2. So I'm substituting -1. So 1/2 times -1 plus 5. Well, this would just be -1/2 plus 5. So that's going to be 4.5. Okay, so -1 comma 4.5. That's my first endpoint. So now let's do 3. So I have 1/2 times 3 plus 5. Half of 3 is 1.5. So I have 1.5 plus 5, so that'll be 6.5. So 3 comma 6.5. The first one is an open circle, the second one is a closed circle because of the or equal to. So open circle, closed circle. All right, so here we go. So I've got -1 comma 4.5. Open circle, and I've got 3, 6.5, closed circle. All right, so that's what the red piece looks like. All right, one more. The green piece. The green piece has one endpoint, and it's going to be at 3 comma something because of the 3 right here. But 3 comma what? Well, looking back at the original function, I've got negative absolute value of x So there goes the 3 minus 5, absolute value plus 3. So this will be negative. 3 minus 5 is negative 2. The absolute value of negative 2 is positive 2, but that negative sign is still out front. And then so I have negative 2 plus 3, so that is 1. So 3 comma 1 is the endpoint of this piece. It will be an open circle because it says greater than 3, not equal to 3. So this point will not be included. So open circle at 3 comma 1. All right, this is the endpoint of this piece. So to see where the rest of the points will go, I'm going to make a table of values. Okay, so here comes my table of values. X, and then y equals, what was it again? Negative absolute value of x minus 5 plus 3. Remember, I need x values that are greater than 3 at this point. So I'm going to do, for example, 4 and 5 and 6. Okay, so if x is 4, then what I have is negative absolute value of 4 minus 5 plus 3. So that's going to be absolute value of negative 1. Okay, so that's going to be positive 1. Whoops, I didn't mean to keep the absolute value sign. So watch this carefully. Absolute value of negative 1 is positive 1, but this negative sign in the front is still there. So that's going to give me positive 2. Okay, so I end up with 4 comma 2. What if I have a 5 in there? So that's going to give me negative absolute value 5 minus 5 and then plus 3. Well, this is 0. And negative 0 is still 0. So I just have 0 plus 3, so I'm going to have 3. Okay, one more. If I substitute in 6, then I have negative absolute value of 6 minus 5 plus 3. So that's the absolute value of 1 plus 3. So absolute value of 1 is 1. I'm just bringing that negative sign down. So that is 2. Boom. Okay, so let's plot those points. So I have 4 comma 2. And I have 5 comma 3. And then I have 6 comma 2. Okay, so look, absolute value functions make V shapes. All right, if they are positive, it makes an upward facing V like this. If they are negative, it makes a downward facing V like this. This one was negative, so it will make a downward facing V. So you can see what's happening here. All right, this is the vertex of the absolute value function. So now it's going to come down and follow the same slope. So it's going to continue to go down 1 over 1. Just like this went up 1 over 1. This will continue to go down 1 over 1 as it goes off the edge of the graph paper. So that is it for problem number 9. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.